a week during the early stages of the blitzkrieg into Russia. The German army captured and destroyed 5 Soviet armies, including 22 infantry divisions, 7 tank divisions, and 6 mechanized brigades. The Germans, during ideal weather, moved rapidly, fully exploiting their superior mobility. The 24th German Armored Division was not so fortunate in January 1944. The division was ordered on a 300-kilometer march to block an anticipated Soviet breakthrough. The roads in the region were saturated, and even fully tracked vehicles were slowed to a few kilometers per hour. Only 12 tanks, 1 artillery battery, and a handful of infantry completed the journey. The remainder of the equipment mired in the dark mud of the Dnieper Plain. The Soviets captured the bulk of the German division's equipment. The combat report of the 24th Division condensed this experience thusly: mud is the greatest enemy of the armored division. Terrain often dictates how a battle is fought. A successful battlefield commander recognizes both the limitations and opportunities the terrain offers. The ill-fated movement of the 24th German Armored Division provides a vivid lesson. Often the final outcome of a battle is a direct reflection of the commander's understanding of terrain.
Army terrain analysis finally enters the computer age with the fielding of MICROFIX topographic workstation. Terrain analysts in division, corps, and theater engineer terrain detachments can now use computers to calculate line-of-sight profiles, assess placement locations for weapons, radars, or radios, view three-dimensional representations of the terrain, estimate cross-country mobility, and perform a host of climate and weather-related tasks. The United States Army Forces Command conceived MICROFIX as a quick reaction capability for the 18th Airborne Corps. The system was designed to improve the productivity of intelligence analysts in the G2 all-source production section, but it has now been adapted to support the commander's need for terrain information. The system was created from off-the-shelf commercial components and was officially designated AN/UYK71. This MICROFIX hardware consists of an Apple II Plus microcomputer with a number of enhancements. This green Apple has twice the computing power and over 5 times the memory capacity of a standard Apple. Peripherals connected to the processor include a hard disk that stores over 20 million characters, both monochrome and color monitors, a dot matrix printer, a video tape recorder, and a laser disc. The video tape recorder provides backup copies of the information on the hard disk and loads digital terrain data from pre-recorded tapes. The laser disc serves as a map library with up to 50,000 map images on a single disc, which the computer can display on the color monitor and overlay with military symbols. All components mount in sturdy cases to meet Tempest certification and field use specifications. In 1984, the Belvoir Research, Development, and Engineering Center proposed the use of MICROFIX as a tool to define topographic requirements for automation from field experience. Working with the Computer Graphics Laboratory at the United States Military Academy, Belvoir Research, Development, and Engineering Center placed MICROFIX systems in 1 theater, 1 corps, and 1 division-level terrain unit for test and evaluation. Reports from these evaluations help to define the unique automation needs of Army topographic units supporting the commander on the battlefield and led to the concept of a MICROFIX topographic users package. Development of the topographic package began in the summer of 1985 with the Computer Graphics Laboratory coordinating a cooperative effort of 4 departments of the Army Labs and the United States Army Forces Command. MICROFIX currently is the only Army standard computer system to support the battlefield commander's topographic needs. MICROFIX is a first-generation system. However, it has and will continue to perform the invaluable function of identifying key areas for future development while providing a usable interim system. This use, learn, develop philosophy is at the core of the whole MICROFIX project. Developers provided a working prototype quickly. It was fielded and users provided immediate feedback. This was incorporated in successive versions so that each new product more closely matched user needs. Researchers are already working on the next logical development, seeking to capitalize on improvements in computer technology that have appeared since MICROFIX was first fielded. Software is ready for an MS-DOS system that runs 3 to 4 times faster than MICROFIX, with increased storage capability and higher screen resolution. Dubbed TopoFix, this system is being field tested as a cooperative effort between the Computer Graphics Laboratory and the Belvoir Research Development and Engineering Center in the 29th Engineer Battalion, Topographic, in the Pacific Theater. A MICROVAX version of topographic software written in Ada is in development. The MICROFIX topographic configuration contains 2 parts. A baseline configuration common to all MICROFIX systems, including military intelligence systems, and the topographic package. The baseline software maintains graphic and text databases that can be overlaid on maps stored on the system's video disk unit. The topographic package represents a cooperative effort among Army laboratories. The Atmospheric Sciences Laboratory at White Sands, New Mexico provided the Tactical Weather Intelligence System. The Engineer Topographic Laboratories at Fort Belvoir, Virginia provided the Battlefield Environmental Effects software. The Waterways Experiment Station, Vicksburg, Mississippi provided a mobility evaluation module. The Computer Graphics Laboratory at the U.S. Military Academy, West Point, New York, provided a digital terrain analysis program called Terranal and coordinated the integration of the topographic package. Tactical weather intelligence software on MICROFIX assists the analyst in 5 types of planning: NBC operations, mission-oriented protective posture, smoke operations, use of night vision goggles by aviators, and employment of electro-optical target acquisition devices. The package aims to assist the terrain analyst and the staff weather officer, but clearly benefits all tactical planners. Battlefield Environmental Effects software provides 6 major functions: historical climatologies for several prospective theaters of operations, helicopter density altitude calculations, sun and moon rise almanac determinations, cross-country mobility calculations, combat engineering obstacle planning from FN 5-34, and utility conversion routines. As with the tactical weather intelligence software, the Battlefield Environmental Effects software provides computerized planning assistance for many staff functions. The Terranal program provides digital topographic support to MICROFIX. The program uses digital terrain elevation data produced by the Defense Mapping Agency. Characteristics of the data limit its capability and require careful analysis of results. Despite this limitation, digital terrain elevation data is available for most of the Northern Hemisphere. Data sets used by the computer cover 30 minutes of latitude by 30 minutes of longitude, which corresponds to 4 standard 1 to 50,000 maps. The digital terrain elevation data retains its geographic coordinate base on the MICROFIX, with the computer handling the transformations to and from the UTM coordinates input by the user. The configuration of the MICROFIX hard disk allows up to 6 data sets to be loaded and accessed simultaneously. The user loads additional data sets from videotape. Taranal will produce the following 5 types of output on the color monitor, which can be reproduced on the system's dot matrix printer. Line of sight profiles, weapons sensor masking plots, colored hinted elevation maps, slope maps, and oblique views. Images generated by these functions can be stored on the hard disk and then recalled to the screen for briefings or further analysis. The cooperative efforts have resulted in a new capability for terrain analysts in division, corps, and theater terrain teams to maintain and analyze terrain, weather, and engineering data. The MICROFIX topographic workstation has had the following important benefits to the Army. 1, terrain teams received automation support, the first significant advance in terrain analysis capability since World War II. 2, feedback was amassed as input for the developers of more sophisticated systems that will eventually replace MICROFIX. 3, soldiers were trained on a relatively simple system. These are the same people who will use or supervise the use of the complex systems under development today. We all realize that MICROFIX is not the optimal topographic workstation. It was never meant to be. However, use, learn, develop will continue. And the partnership between the United States Military Academy, Army Laboratories, the United States Army Forces Command, and users will create successively better systems to meet the needs of combined arms commanders in the field army.
As the commander of the 24th German Armored Division discovered, a knowledge of the terrain is often the beginning and the end of tactics. Other things being equal, victory goes to the commander who best understands the terrain.
The preceding was a television presentation of the Audiovisual Instructional Technology Division, United States Military Academy.